Let us look at proposition number 3 of book 9 of Euclid's Elements. The proposition says, if a cubic number is multiplied by itself, makes some number, then the product is a cube. So let's see how to prove that. Given a cubic number a, let b is equal to a times a. So a cubic number multiplied by itself makes some number, then the product is a cube. So the proposition is saying that b should also be a cube. Let c be a side of a. Let d is equal to c times c. That is, let d be c multiplied by itself. So can we say a is equal to c times d? Just try to figure out. Remember, a is a cubic number. Now c is a side of a, and d is the other two sides, product of other two sides. So we can say a is equal to side times the product of two other sides. So a is equal to c times d. Okay. So what this tells us is c measures d based on the units in c. So which means we can say unit is to c as c is to d. Now let's look at a is equal to c times d. D measures a based on the units in c. So which means we can say unit is to c is equal to d is to a. Here you see left hand side, unit is to c, unit is to c. So that means we can combine them and say unit is to c is equal to c is to d is equal to d is to a. So here if you notice, c and d are the mean proportionals between unit and a. There are two mean proportional numbers between unit and a in continued proportion. Now let's take the next part. B is equal to a times a. That means a measures b based on the units in a. Now we can also see that unit measures a based on the units in a. So which means we can write it as unit is to a is equal to a is to b. Unit is to a as a is to b, because both unit and a measure a and b the same number of times. You see, unit is to a, we have already seen that there are two mean proportional numbers between them, between unit and a in continued proportion. That means based on this proportion, we can say a is to b also has two mean proportionals between a and b in continued proportion. And we have already seen that if there are two mean proportional numbers, and if a is a cube, then b is also a cube, which is what we had to prove, that b is also a cube. So that is proposition number 3 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail with proper references to the previous propositions. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.